In this lesson, we are studying the binomial series. Actually, the binomial series is different from the usual binomial theorem expansion. Whenever in this case, whenever you see the whole power n, and but n is not a positive integer, instead it can be a fraction or a negative integer, then the usual binomial theorem is not valid here. The reason behind this, because of that the NCR is not defined for the negative number or for the fractions. So you cannot use the usual binomial expansion to expand such a term. Therefore, we have a new formula for this: 1 plus x whole raised to the power n. And here the first term will always be equals to 1, and this will be something x hoga. And then we use this formula, always write the first term as 1. Then plus the second term is always the product of n and the x. Here is the product of n and x. And the third term, look here, third term n into n minus 1. You will decrease n by 1 and whole divided by 2 and increase the power of x. Here the power of x was 1. Here the power of x is 2. I'm repeating. The first term is always 1 and the second term is always the product of this. Then the third term will be n times n minus 1 by the 2 factorial. And similarly, the third term is this, and the fourth term n multiplied by n minus 1 is it as it is, and then we write n minus 2 whole by 3 factorial and write the x cube and so on. You can write many terms of this binomial series expansion, and particularly this is known as binomial series instead of binomial expansion. I'm repeating how to use the formula. Here always the first term is 1 and then the second term is n into x, so that everyone can write the first two terms. The third term, however, the third term is n into n minus 1 number less than n divided by the 2 factorial into x square. And similarly for the fourth term, we always increase one more factor, that is n minus 2, and write the, instead of 2 factorial, here you write the 3 factorial and x cube and so on. You can write many terms. There is no end of the expansion in this case. In binomial expansion, you know there are limited terms depending upon the value of n. In binomial expansion, the number of terms is one more than the n. But in binomial series, the terms are infinity. This is the first difference. The second difference is the n is not a whole number, positive whole number. This is the difference. And the third difference, this term x, it always lies between 1 and minus 1, or you can say its absolute value is less than 1. So you always keep in mind, otherwise it will not be valid. And you know this can also be written as x lying between 1 and the minus 1. So this is the validity for the binomial series expansion, and otherwise it not be valid. Now by using this formula, we are going to expand some of the examples. First of all, I am taking this example. I already expanded it to save my time. So usually by using this formula, you know, I said the first term is always 1 and the second term is the product of the power and this x. And the third term is the product of n into n minus 1, as in you can see in this formula divided by 2 factorial. The third term is x square, and so you can also write the fourth term, but I'm writing only the first three terms. Usually in your exam, the examiner demand only the first three terms. It's very rare the examiners say the find the fourth term as well. So after simplification of the coefficients, we finally get this answer. So this is the complete expansion in case the power is not the whole number. Now come to the other example where the power is a negative number. It's not a positive whole number. So we always write the first number as it is, and then write the product of this. Here is the product. Then write n into n minus 1. N is negative 1. So we write negative 1 into negative 1, negative 1 divided by 2 factorial. Then this 3x whole square. So we, after simplifications, I can get 1 as it is. And this is the product. It is product of minus 1 and 3. So it becomes minus 3x and plus. It is negative 1 into negative 2. So it becomes positive 2. Positive 2 is cancelled with the factorial. So we get this is 1 and it is 9x square. So we get the 9x square. So this is the complete expansion for the this binomial series. But so far as the validity is concerned, we are saying we want to say this term must be between 1 and minus 1 like this. This is the condition for the validity. If the examiner asks the question, write the set of values of x for which the expansion is valid. So you will do this in this way. It is usually 1 mark question. And for the validity, 3x must be less than 1 and greater than negative 1. If I divide the whole inequality by positive 3 and dividing it by positive 3, it is 1 by 3. And this is the x and it is 1 by 3. So we have the range of the values of f for which this expansion is valid. So we get the answer of the second example. Now come to the third example. First of all, write this expression as the power 1 by 2 and take this in the numerator. We can write this 1 minus 3x raised to the power negative 1 by 2. To avoid any mistake, we can also write this expression as in form of plus and taking the 3 with the x. And we write this negative 1 by 2. And then using this formula, expand this and as usual, we write the first term 1, the second term, the product of these minus 1 by 2 into minus 3. And the third term, negative 1 by 2, negative 1 by 2, negative 1 divided by 2 factorial. And here the minus 3x whole square and so on. Write all the terms after this. So the terms are infinity here also. Now after simplifications, I want to write the final answer 1 plus 3 by 2 because after the product of minus 1 by 2 and the plus 3 minus 3 is answer is this is x and then multiplication of these two terms, it is 1 by 3, it is 3 by 2. If you simplify this yourself, you can see 1 by 2 minus 1, it will be minus 3 by 2. If you multiply minus 3 by 2 with minus 1 by 2, it becomes negative 3 by 2 into negative 1 by 2, it becomes 3 by 4 and whole divided by this 2, it becomes 3 by 8. And of course, this is also 9. So you can write this as 3 by 8 into 9. So it will be positive term because this negative, this become positive, it will be. So your answer is 3 by 8 into 9. So we can say it is 27 divided by 8. X raised to the power 2 and so on. You can write the infinite many terms of this binomial expansion. So far as its validity is concerned, we once again write the minus 3 lying between minus 1 or 3, then you can write its values of x for which it is valid. There are, I think, more possibly some more questions from students or viewers. Someone can say if there is this is not one, how to make this one, or someone can say there are three terms in the here instead of two, how to expand it. So in this concept I will cover in my upcoming classes. So up till this, because the video become very lengthy, otherwise you will get bored with the long videos. And overall, I'm repeating the concept whenever 1 plus x whole power n, it is not a positive integer. You cannot use the binomial expansion. You keep in your mind this is the formula, and keep in your mind this is always equals to 1. This for the validity of the expansion, the x must be lying between 1 and -1, and these are the two examples and these are answers. I think everything covered so far as the introduction of the binomial theorem is concerned. I think now there is no issue for all of you. Thank you very much. Thank you for watching my video, and enjoy with the binomial series. Thank you and goodbye. Allah Hafiz.